Hello everyone. In this video, we'll continue to provide a training course for the AWS certificate on Generative AI Developer Professional, where in this video we'll talk about the implementation and the integration services provided by AWS. We'll start by AWS Step Function. It's a service for orchestrating workflows, chaining together multiple steps with error handling, retries, and conditional logic. You define a state machine using Amazon State Language, JSON, and the step function executes it. As shown in the diagram, this is an example of the step function. For generative AI applications, a step function is used for complex workflows that involve multiple foundation model calls, data transformations, and external service integrations. You might use it to implement react, reason, and act patterns, a chain of thoughts, reasoning, or multi-agent systems. The key features are parallel execution, error handling, and human approval steps in using step functions. You can use multiple branches in parallel, catch errors, and retry with exponential back off. You will see this in the exam. And pause workflows for human review before continuing. This is human in the loop feature we provide for generative AI using AWS step function. AWS step function integrates directly with Amazon Bedrock, Lambda, DynamoDB, loads of other AWS services. You can invoke Amazon Bedrock model, process the response in Lambda, store the results back in DynamoDB, and send notifications via SNS, all orchestrated by AWS step function without writing glue code. Express flows are for high volume, short duration workflows up to 5 minutes. Standard workflows are for longer running processes up to a year. For generative AI applications, you would typically use standard workflows because foundation model calls can be slow and you want the full audit trail. The difference between AWS step function and the Bedrock prompt flows is that step function is general purpose orchestration with full AWS service integration, but in prompt flows is specifically designed for generative AI workflows and has a visual builder. For complex orchestration with sophisticated error handling, we will use step functions. It's more powerful in these situations. For similar generative AI workflows, we'll use prompt flows. It's easier in these situations. Next, we'll talk about Amazon Bedrock, Amazon Event Bridge. Event Bridge actually is an event bus. It routes events from multiple sources to targets based on rules. Events are JSON messages that describe something that happened. You create rules that match event patterns and route matching events to specified targets. Event Bridge for generative AI, we use Event Bridge is useful for event-driven architectures. You might trigger a workflow when a document is uploaded to S3 and when a model finishes the processing or when a user submits a form. Event Bridge decouples your components. The event source doesn't need to know about the target. Actually, AWS Event Bridge supports custom event buses for your own events plus integration with AWS services like S3, DynamoDB, and SaaS applications like Salesforce, Zendesk. You can also schedule events using a cron expression or rate expressions. Event patterns use JSON matching. You define what events to match based on fields in the event. For example, you might match S3 events only for specific buckets or file extensions. Event bridge routes matching events to targets like Lambda, step function, SQS, or SNS. The use case for generative AI is loose coupling. Rather than having your application directly call the next step, it publishes an event. Event bridge routes that event to whatever needs to handle it. Makes it easier to add new functionality without it changing existing code. Next, to talk about AWS Lambda. Lambda is serverless compute. You write functions, and AWS runs them in response to events. You don't manage servers, just deploy code. Lambda scales automatically, and you pay only for the execution time. For generative AI applications, Lambda is everywhere. It is the glue code between services, pre-processing data before sending it to foundation model, post-processing responses, calling external APIs, implementing custom logic in step functions, workflows, and handling webhooks. All of this handled in AWS Lambda. Lambda functions can be triggered by loads of things. For example, from API gateway requests, S3 uploads, event bridge, events, step function tasks, or direct invocation. For generative AI application, you would typically use Lambda for pre-processing user input before sending to foundation models, post-processing model responses like formatting, validating, and storage, implementing action groups for Bedrock agents, custom logic in step function workflows, and in webhook handlers for external integrations. Lambda has 15 minutes timeout, which can be a problem for long-running foundation model calls. For synchronous API calls, you would limit it to 29 seconds API gateway timeout. For longer operation, you would use asynchronous invocation or step functions. Lambda layers you Lambda layers let you share code and dependencies across functions. For generative AI applications, you might have a layer with your prompt templates, common utilities, or SDK configurations. Next, talk about Lambda durable functions. Durable functions is a new capability launched December 2025 that extends Lambda with built-in workflow orchestration. It lets you build multi-step applications directly within Lambda using a standard programming language with automatic state management and failure recovery. Note, this is quite new, so it might not appear in the exam immediately. The exam content typically lags behind new service launched by few months. However, it's worth understanding because it's likely to be included in the future exam versions. So it represents important evolution in Lambda capabilities. Durable functions use checkpoint and replay mechanism. As your code executes, Lambda automatically checkpoints progress at specific points, called steps. If a failure occurs, Lambda replays the function from that last checkpoint rather than starting over. This makes your code resilient without writing custom retry logic. The key features of durable functions: steps. It has steps. Wrap operation steps to checkpoint progress. If a step fails, it retries automatically without re-executing previous steps. It has also waits, suspends execution for up to 1 year without incurring computed charges, useful for waiting on external approvals, scheduled tasks, or long-running processes. It has also a feature of automatic state management. Lambda persists your workflow state automatically. You don't need DynamoDB or external storage for this. It has built-in error handling, configure retry strategies, timeout, and error handling per step. Lambda durable function, we can use it for generative AI applications. It's useful for multi-step AI workflows, for chain multiple foundation model calls with conditional logic and error handling. Also, it's very useful in human in the loop, pause execution whilst waiting for human approval or generated output. It's also useful for long-running document processing, process large documents in steps, checkpointing progress to handle failures gracefully. And it also used in agentic workflows, implement react patterns, reason and acting, or multi-agent systems with automatic state management. The code uses Lambda execution SDK available for Python and Node.js. You write normal Lambda code but use Lambda operations like step and wait. For example, as you can see here, we have an example from Lambda durable function. It's called it's handler. I'm using here durable.step call and durable.wait. Okay, and variable.step here I define the steps defined in the code for durable functions. The difference between durable functions and the step function is that durable functions run within Lambda using code, while step function is a separate service with visual workflows. Durable functions are better for application logic within Lambda, where you want to fine-grained control, but the step functions are better for orchestrating multiple AWS services with visual representation. You can use both together. Durable functions for application level logic within Lambda and the step function for high-level orchestration across services. For example, step functions might orchestrate a workflow that calls multiple durable functions, each handling complex multi-step logic. Durable functions are currently available in US, East Ohio, and support Python 3.3 and 14, and Node.js version 22 and 24. They are quite new. Actually, it's launched in December 2025. So exam covered might be limited initially, but they are important for understanding modern Lambda patterns, and it will likely appear in future exam versions. Thank you guys for watching this video. I hope you like this video, and if you have any questions you can comment on the video, and please subscribe to my channel so that you can follow up on the future videos we will provide on my channel. Thank you.